Good morning. I thought I would do another puzzle. This is the set of new puzzles from Logic Masters Deutschland. I did Rainbow Whispers last night. That was a lot of fun, although I didn't make a video out of it. I was thinking we could do a 1-star or a 2-star puzzle. This one is called Even Cages Even. This one's called Equal Light Cages 101, an introduction to equal light cages. I don't know what to do. I could do the 2-star. I could do sequentially quiet. The 3-star and 4-star puzzles take me over an hour, and I don't know if I have too much time now. Maybe we could do even cages even. This seems like a fine puzzle for the morning. Even Cages Even by Daniël Rokven. It has 152 solvers and lasts 13.7 days. So this is a pretty new puzzle, and we are going to solve it, or we're going to try to. What are the rules? Even cages even. Normal Sudoku rules apply. In every row, column, and 3x3 box, the digits from 1 to 9 have to appear at least once with no repeats. Okay, that's a way to phrase the normal Sudoku rules. There are killer cages. Digits in cages must sum to the number in the top left corner of the cage and cannot repeat. Cages are made up of only even digits. Even cages. That's interesting. Now I get the name, and I think that is going to that's going to maybe make it easier to fill out these cages. And then non-consecutive. Cells that are orthogonally adjacent cannot contain consecutive digits. I think that's going to be a tough rule. But we only really have 2 novel rules in the puzzle. The first has to do with these killer cages. When we see a cage, this one has a little 10 in the corner, that means that these 2 digits sum up to 10. But we're given the extra rule that the cages are made up of only even digits. That means that in this region here that has a 10 in it, we're going to need the numbers. Well, how could we add to 10? We could add to 10 with 2 and 8. That's a way of adding to 10, or 6 and 4. And that covers all of the even digits. In fact, here, it's the same business. These add to 10. This is going to need to use the numbers either 2 and 8 to add to 10. Maybe this is 2 and this is 8, or 6 and 4. And now in this region, we've exhausted all of the even digits. We know that the even digits go in the cages. So that is, I think, where we're going to start, See, there are only 4 even digits on the keypad. Every row, column, and region needs to be made up of unique digits. So when we have a column here that has 4 cage cells, we know what goes in these cage cells. It's the even digits, 2, 4, 6, and 8. And if we add these up, we're going to get 20. It's the same thing here. You need to be the numbers 2, 4, 6, and 8. 2, 4, 6, and 8. All of the cages are made up with the even digits. In every row, column, and region, we're going to need 4 even digits. That might, so then these can only contain the numbers 2, 4, 6, and 8. But I do wonder about how we're going to do it down here. You see, these need to add to 12. If there was an 8 in this region, then I don't think we could add to 12. We could have 8 and 2 and 4. This would add to 14. I think this needs to be the numbers 2, 4, and 6. And now the extra 8 that goes in the region, the missing even number, needs to go up here. So now you are not allowed to be an 8. I should have started up here with this 8. How are we going to add to 8 with even digits? Well, I can't use 4 and 4. That would create a repeat. I need to use 2 and 6. You need to be the numbers 2 and 6. And now the extra even digits, they're going to go in the rest, the other 4 cells. You need to be the numbers 4 and 8. Now you all need to add to 18. You add to 12, which means you need to be a 6. You need to be a 6, definitely. Neither of you are allowed to be 6. In this column, we're going to need some even digits. We already know where the 2 and the 6 go. That means you need to be the numbers 4 and 8 in some order. And if this is a 6 and this is 4 and 8, this needs to be a 2. This is the only even digit left for this region. And now 2 plus 4 plus 8 is going to give us 14. We need to add to 20 in the end. This needs to be a 6. And now what? I should go and mark what we've learned over there, but I'm not going to yet. You need to add to 12. You need to use even digits. You can't use 2 and 6. You need to be the numbers 4 and 8. All right, now you are not allowed to be a 2. You are not allowed to be a 6. You guys need to add to 18. Is it possible to add to 18 with a 2? If I had a 2, then the maximum sum that I could create with even digits has 6 and 8 in it. These add to 14. The 2 would make this 16. I think you're not allowed to have a 2. I think you need to be the numbers 4, 6, and 8. And that means that you need to be either 4 or 8, and we're going to need a 2 somewhere else. But if in this column we know where the 4, 8, and 6 go, there's another even digit in that column. This needs to be a 2. And now you need to sum to 10, which means you need to be an 8. Now you need to be the numbers 4 and 6. You need to be the numbers 4 and 6. Excuse me. You need to be the numbers 4 and 6. You, we know what you go are. Now we know what you are. Yeah. This is an interesting, I don't know if I've done even cages yet. Even cages, even. This is a cool little rule. We need another even digit in this column. I think the even digit, since this needs to be an even digit, and there are going to be 4 even digits in the column, we know where 3 of them are. You need to be even, but we also know what goes here. You can't be a 4, 6, or 8. You need to be a 2. And now what goes here? Well, you need to be unique even digits, so you can't contain a 2, but you're not allowed to be 8 or 6. You need to be 4. And now you need to be an 8 so that in the end we can sum to 14. Now you need to be a 4, and you need to be an 8, you need to be a 2, you need to be a 6, and you need to be a 4. So a lot of progress has been made. Let's see. In this row, we will need a 4, 8, and a 6, and that is what is available in these cells. Yeah, interesting. Interesting. I don't know. I wonder if we've exhausted the even cages rule for now. And the only other rule that we can latch onto is this non-consecutive rule. Maybe we should figure out where the odd numbers go. So the odd numbers that we're allowed to work with are 1, 3, 5, and 7, and 9, excuse me. 1, 3, 5, 7, and 9. There's 5 odd digits, and that's what's going to populate these cells that are not even. But I have a feeling it's going to become pretty difficult if we start filling in these to figure out, figure things out. For example, where could a 1 go in this region? Well, it can't border the 2. So a 1 needs to go out here somewhere. I don't know if that's the thing to do, but where does a 3 need to go in this region? A 3 also can't border the 2. The 3 needs to go out here. And I wish I could shove in 1 more, but I don't think we can. Wish I could say that a 5 needs to go out here with them, but I don't think that's the case. Interesting. So maybe we should start with the odd digits, but maybe this was the wrong region to start with. What is a good region to start with? What is a good region to start with? I could do some other things. Maybe before we move on to the odd digits, we should think about the missing even digits. This region needs a 2. That 2 can't go in either of these columns, and it can't go here. There needs to be a 2 either here or here. Are there any more regions that only have 3 even? See, this needs a 2. 2 can't go here. It can't go in this column because we already know where the 2 goes in that column. There needs to be a 2 down here someplace. Ah, but neither of you are allowed to be 2s. You need to be a 2. 9 minutes into the puzzle, but I feel pretty good about where we are. Yeah, I should think about the even numbers in the rows and columns, maybe. This is an example of a row where we only know where 3 of the 4 even digits go. We need to place a 6 somewhere. That 6 is going to need to appear here. Can't actually appear in the middle. And I don't think it can appear here. I think you need to be a 6. And now, because of the fact that you're definitely a 6, you need to be the numbers 1 and 3. So now where does a 5 need to go in this region? Well, the 5 isn't allowed to touch the 4 or the 6 because they're consecutive, and it can't go in either of these cells with the 1 and the 3. You need to be a 5. And now you need to be the numbers 7 and 9. 7 can't touch the 6. You need to be a 7, and you need to be a 9. Yeah, I feel like we're doing all right. Feel like we're doing all right. Are there any more even numbers to fill in? This needs to be, well, I suppose we don't know what these need to be. This could be 2 and 4, or it could be 2 and 8, or it could be 4 and 8. There's a lot of variability there. I guess there needs to be a 4 in one of these 3 cells, and there needs to be a 2 in one of these 3 cells, and there needs to be a 6 in one of these 3 cells. That means that you need to be an 8, and now you need to be a 4, and now you need to be a 2. Now you need to be a 2. 2 can't go here. You guys need to be 2 and 4, so you're not allowed to be 8. You're not allowed to be a 2. You 2 aren't allowed to be 4s. Yeah. So now we need an 8 in this region. That 8 can't go in this column. It can't go in these 2 rows. You need to be an 8. Are there more to fill in? Are there any regions where we don't know where 4 even numbers go? Are there any rows or columns where we don't know where 4 even numbers go? I think we have them all. I think we have them all. So now I guess we do need to move on to the odd numbers, and we need to place them basically using this non-consecutive rule. So where does a 1 go in this region? Well, it's not allowed to go out here. It's not allowed to touch the 2, and neither is the 3. You must be 1 and a 3. You must be, 1 and 3. And now, in this column, we're missing a 5. We know where the 1, 2, 7, 9 go. You need to be a 5. I also need to place out here a 7 and a 9. I need to place a 5 somewhere in this region. That 5 can't go here. It also can't touch the 6. So one of you 2 must be a 5. One of you 2 must be a 5. We should use the other numbers. I don't know if 5 was the place to start. Maybe I should have started again. In this column, we need to fill in some numbers up here. We need to know, we need to place a 1 up here someplace. We also need to place a 3 and a 5 up here someplace. These are certainly the numbers 1, 3, and 5. These are certainly the numbers 4 and 6. This is 2 and 8. I think that means you need to be 7 and 9. We might have been able to figure that out a little bit earlier. Continuing, but continuing how? I wish I could rule out more 1s or something like that. One of you 2 must be a 5. Regardless of whether or not the 4 or the 6 goes, maybe this is 4 and this is 6, or maybe this is 6 and this is 4, but neither of you 2 can be 5. So one of you 2 must be a 5. One of you two must be a 5. I guess I also need to place a 7 and a 9. No, that seems a bit like overkill. I'm not quite sure. In this region, we need a 5. That 5 needs to go up here. In this region down here, we need a 5. That 5 can only go here or here. I have less faith with starting with the 5. It's the middle number. I have more faith with starting with like a 1 or a 9, trying to fill in where those go, but somehow I keep getting sucked back into 5s. All right, we need to place a 1 and a 3 in this region somewhere. They can't touch the 2. The 1 and the 3 need to go out here. We also need to place... the 1 and the 3 need to go out here. I don't know if that was the place to start. I could just, we could fill in all of the numbers. I don't know how I feel about that. In this row, this is going to be a 1 or a 3. That's going to force this to be a 1 or a 3. If the 1 goes here, then a 1 needs to go here. You can only be the numbers 1 and 3. And then you can be 1, 3, or some other number. But you must be a 1 or a 3. And then in this row, one of you two must be a 1 or a 3. Interesting. I need to place a 7 somewhere in this region, but that 7 can't go here or here because these both touch 7 and 8. So one of you must be a 7. One of you must be a 7. So now down here I need to place odd numbers. I'm only allowed to use the numbers 1, 3, and 9 because those are the numbers that don't appear in the column already. You can't be a 9. It's a pretty fair game what you are, though. Interesting. Interesting. We need to make more progress, and I'm not quite sure where yet. I need to place a 7 in this row. That 7 could go here, but importantly, it can't go in here or here because of the 6 and the 8. Yeah, I need a 7 down here somewhere. That 7 can't touch the 6. It also can't touch the 8. One of you two must be a 7. One of you two must be a 7. And now I need a 7 in this region someplace. Can't go in this row. We have a 7. Can't go in this row. We have a 7. It needs to go here or here, but you must be a 1 or a 3, which means you must be a 7. You must be a 7. Now I need to place a 9 somewhere. That 9 can't go here, which means one of you two needs to be a 9. One of you two must be a 9. But now we have 3 cells and 3 numbers. 1, 3, and 9 definitely occupy these 3 cells. The remaining number is 5. You need to be a 5. Now you need to be a 5. And now you can no longer be 5. It's an interesting rule, the non-consecutive rule. Digits that are orthogonally adjacent cannot contain consecutive digits is an interesting rule because of the fact that we know where all of the even numbers go. And an even number is always going to be consecutive with an odd number, and an odd number is always going to be consecutive with an even number. So yeah, the missing number down here, you guys, we need a 7 down here, but we also need a 1 or a 3. In this row, we're missing a 9. That 9 can't go here because of the 8. You need to be a 9. And now U can be a 1 or a 3. U can only be a 1 or a 3. U, 2, U can only be a 1, 3, or a 7. The numbers 1, 3, and 7 definitely go down here. Yeah. We need to use the even numbers together somehow with this non-consecutive rule to place the remaining digits. We are 19 minutes in. There needs to be a 9 somewhere in this region. That 9 needs to appear out here. So one of you is certainly a 9. And now is there another thing that we could sort of shove up there with you? I'm not quite sure. We don't know where the 1, the 3, and the 7 go in this region. 7 isn't allowed to touch the 8. So a 7 can only go down here. My inkling is that we need to play with the odd numbers because we have most of the positions of the even numbers. But I didn't think about applying the non-consecutive rule when we started filling in odd numbers. You're no longer allowed to be a 6 because of this 5. You need to be an 8. Now you need to be a 6. Now you need to be a 4. Now you need to be an 8. Now you need to be a 4, and you need to be a 6. And things become much harder for us, I think. I think they do. You need to be a 6, which means you actually can't be a 5 or a 7. You two need to be the numbers 5 and 7. In this column, we're missing a 9, and that 9 now needs to go here. You need to be a 9. In this region, we're missing a 1 and a 3. That 1 and 3 need to go here. You need to be 1 and 3. You need to be 5 and 7, which I'll notate with the center numbers for now. Now we're missing a 7 in this column, and that 7 has to pair with you guys. So there needs to be a 7 in here someplace. But this is counted to an 8, so you can't be 7 or a 9. You need to be 5, and now you two are 7 and 9. You are no longer allowed to be a 5. That means you need to be a 5. You need to be a 5, and that's all allowed. You are right next to this 4, which means you're not allowed to be a 3 because of the non-consecutive rule. It'd be nice if we could rule one more out, but I don't think we can. You are not allowed to be a 3 either because of this 4. You need to be a 1. Ugh. You need to be a 1, and now you need to be a 3. You are certainly the numbers 4 and 6. And the thing about 4 and 6 is they both are connected to 5. You can't be a 5 because you would have a consecutive number next to you, so you need to be a 5. Now you need to be the numbers 1 and 3. Now in this row, I'm missing a 1, 3, and 7. The 3 is not allowed to go here because of the 4. So you can only be 1 or 7. You can be 1, 3, or 7. In this row, we're missing a 7, a 9, and a 3. But you're not allowed to be a 3 or a 7 because of the 4 and the 6. You need to be a 9. Now you need to be a 7. Now you need to be a 9. Now you need to be a 3. You need to be 1 and 3, which means you are 9. You need to be a 7. You need to be a 9. We're all groovy. I think that this is all working out for us so far. Where are the numbers 1 and 3? Missing some numbers in here. What are we missing? A 1 and a 3. That 3 isn't allowed to be connected to the 4, so you need to be a 3 and you need to be a 1, and that's all groovy. Now you need to be a 7, and so you two need to be the numbers 1 and 3. This seems to work out, but you're not allowed to be a 3 because of the 4 here. You need to be a 1. You need to be a 3. Now you need to be a 1. Now you need to be a 3. Now you need to be a 3, and you need to be a 1. You need to be a 7, and now you need to be a 1. Now the 7 is connected to 6. You're not allowed to be a 6. You need to be a 2. Now you need to be a 6. Now you need to be a 4, and you need to be a 6. You need to be a 2, and you need to be a 4. You need to be a 3. You need to be a 1. You need to be a 3. You need to be a 1. 7 is connected to 6. You can't be a 7. You need to be a 9, and now you need to be a 7. You would need to be a 5, and you would need to be a 7. And we just have a couple things left to do. We need to figure out where the 1 goes in this region. It can't be next to the 2. And now we need to figure out where the 7 goes in this region. I think we're cool to put it there. A 9 needs to go up here someplace. And a 9 needs to go in one of these two. What's the remaining number in this row that we're missing? We're missing a 5. And now we need a 3. That 3 needs to go here, and we need a 9. That 9 needs to go here. And at the end of the game, we put a 3 in the corner and got a little bit of confetti, but I'm not sure anyone saw that but me. We finished in exactly 25 minutes. Yay, congrats, you solved the puzzle. The solution is correct. 25 minutes, we are the 157th solver in 13.7 days. Even Cages, Even by Daniël Rokven. I really enjoyed that one. Yeah, never played a puzzle with even cages, but it's a cool combination of rules. Yeah, I'm not sure I'm ever going to make my own Sudoku, but I've figured out a way to do it. It's to figure out 2 rules, or to invent 2 rules that have interesting interplay. And in this case, the interesting interplay happens when you have to deal with consecutive digits, and you have to separate the even and odd numbers, because the even numbers are always consecutive with an odd number. The odd numbers are always consecutive with an even number, and then you have all this interplay. But really cool puzzle, Danielle. Hope to do more soon. Anyway, thanks for watching.